So remember, the conditional if A then B is false only when A is true and B is false. Can we find a logically equivalent statement? While finding logically equivalent statements is hard, the problem exists whether or not we know how to solve it. So let's first of all construct our truth table for if A then B. So there are two simple statements, A and B, and there's all sorts of possibilities for their truth values. And remember, the only time that a conditional is going to be false is when the antecedent is true and the consequent is false. And so that's in this case. And in every other case, the conditional is true. So while we're at it, let's find the inverse, converse, and contrapositive. So remember, the inverse is not A, then not B. The converse is if B, then A. We switch it. And for the contrapositive, we negate the two terms. And so we do need to know the negation of A and the negation of B. And so remember, those have the opposite truth values of whatever A and B have. And again, the conditional is false only when the antecedent is true and the consequent is false. So for our inverse, that only occurs here, and the rest of it's true. And we can find the truth values of the converse and contrapositive. And so from this, we see that the conditional and its contrapositive have the same truth value. And so the conditional and the contrapositive are logically equivalent. And so we can say if A then B is equivalent to if not B, then not A. And a useful strategy, answer other questions. So while the question we're trying to ask is what is the conditional logically equivalent to, we can use our table to find other logical equivalences. And if we look at the table, we see that if not A, then not B, and if B, then A have the same truth values. And so that means the converse and inverse are logically equivalent to each other. So remember, solve it again. While the logical equivalence of the converse and inverse can be read off the truth table, we can also get it from our first conclusion, which was that a conditional and its contrapositive have the same truth value. So if we look at the converse, if B then A, its contrapositive will be, which is the inverse. Now, is there a non-conditional that our conditional is equivalent to? So again, let's take a look at our truth table for if A then B, and notice that our conditional is usually true. This suggests we might compare the conditional to a disjunction. Now, the only time if A then B is false is when A is true and B is false. Since a disjunction is false only when both components are false, then if A is true, not A is false, which suggests we should compare to the disjunction not A or B. So we already know the truth value of B. We can find the truth value of not A, and the truth value of our disjunction will be, and we see that they do have identical truth tables, and so the conditional if A then B has the same truth values as the disjunction not A or B. And it's not a formal proof, but let's do some hand waving. Let's see why it makes sense that if A then B is logically equivalent to not A or B. Now we know that not A or A is always true. But if A is true, and if A then B is true, then B is also true. And so instead of A here, we can replace it with B, and that gives us our not A or B. Now again, this is not actually a proof that the two statements are equivalent. The way you'd prove that is to use the truth table, but it's a good way to remember this peculiar connection between a conditional and a disjunction.